because it's probably more of a low velocity profile and talk about force in newtons. So hopefully everyone gets something out of today, other than people that have things like gym work. So this is Inspire, Institute of Sport. It's in the state of Karnataka in India. Looks very fancy from the outside. You've got the Australian flag here on the far left. But these are the flags of all the coaches that currently exist and live at Inspire. So just keep in mind that as I talk about this presentation about low velocity profiling, most of this will stem from what I was able to do while I was there. So what I had access to was to GymAware, and then I had access to Google Drive, like most people. We didn't have any TeamBuilder or VCP, so I had to sort of develop my own program or system from scratch. So if it doesn't make sense, some of it, go ahead and put your hand up and ask. Or you can just jump on my YouTube channel. I've got some more videos explaining the program I use. But as I said, it's in Karnataka, so Bangalore or Bengaluru, this one here. So it's a 6-hour drive north or a 1-hour plane. For the grand total of $40 for one flight, so it works out pretty well. And if you want to ask any questions about the presentation, go ahead so we can sort of stay on topic. And when I do answer them, I'm not an expert at all. I probably think of Dan Baker as probably an expert. I just try and apply the info as it comes out. So today we're going to look at a bit of current research. I'll try and breeze over that, but obviously not try and talk too fast. Then how we design a force velocity profile as it relates to strength training, a bit of theoretical practical side, then delve into the programming, some auto regulation, and then some practical recommendations. So the main aim of today is to get you thinking outside of this little square. So this one I think everyone gets as part of their kit when they go to the conference or when they purchase a GymAware. Really good as a beginner's guide, but start to think of the force velocity profile and velocity-based training as more of an aid to help with your programming and auto regulation as well. Bit of a useless bit of information, but I just did a little Google Scholar hit just to look at how popular force velocity profiling or velocity-based training is becoming. Obviously, GPS and strength training are sort of the top. This could apply to how a car runs too, it's not particularly with the human body. But velocity-based training sits up pretty high. And then you've even got force velocity profile training here. I hadn't put the word training, otherwise it would have jacked up here. Sits higher than Nordic hamstring periodization, SNZ, and VO2 max. So it's becoming pretty popular. So a quick definition, because we all love definitions, but force velocity profiling, I couldn't find one just as a general strength training tool. It mainly talked about how it relates to power. So the ability to generate a profile that highlights an individual's force, velocity characteristics, and how they relate to maximal power output. The other two follow the same sort of trend. And then, of course, there's no force velocity profiling without VBT. So it's a method for strength and power development using a piece of LPT to track the movement velocity of an exercise, using either the Tendo, the push, or the GymAware. GymAware being more on the expensive side and probably your gold standard. Alright, so just a bit of evidence to back up what I'm going to try and say today. So you've got the load velocity relationship. The relationship between load and velocity when fitted with a second order polynomial has a very strong relationship of 0.98. For every 5% increase in load, so when you jump from 60 to 65, 65 to 70, velocity decreases by an average of, let's just say, 0.08, which is 0.02 for every 1.25% increase. And even after a positive change in 1RM, the same percent lift yields a difference of only 0.0 to 0.01, so basically nothing. When you're comparing weak and strong individuals tend to have a slower failure velocity, and this is potentially due to technical differences in the movement. Alright, so if you take nothing else away from this whole presentation and you only remember this, perfect. Because using velocity-based training or even putting a push or a GymAware on a bar creates intent. So if you just look at this study real quick, it talked about using two types of contractions. We looked at an isometric and an isokinetic contraction of the calf. The participants were told to contract as rapidly as possible. They knew it was going to be either isokinetic or isometric. And then by the end of the study, it actually elicited similar responses in their outcomes. So whether it was an isokinetic or an isometric contraction, it didn't matter, they still elicited the same performance outcomes. Augmented feedback, which is the knowledge of results or knowledge of performance. So in this study, they took professional rugby players, put them into 4 groups. They gave them either immediate feedback, feedback as an average after the set. They showed them a video or they gave them no feedback. And the ones that were given feedback after every rep continued to increase their movement speed, and then were able to retain that after a period of 4 to 6 weeks, I think. So if we're going based on the last two slides, augmented feedback and intent. If your programming is not 100% on point, that's all you have to do. Okay, so let's design a protocol. So if you look at some of the research by Adelaide and Flanagan, this is a really, really good paper, and it highlights a lot of stuff I want to talk about today. So what they suggest is that you go with at least 4 to 6 data points, and you look at a spectrum across 30 to 85% 1RM further if you'd like to. They suggest 2 to 3 reps at 30 to 40%, and then finishing up with 1 rep around 80 to 85%. Really good starting point, but I sort of decided to change things a little bit, and we'll talk about it in a second. But some of the considerations is, are you going to choose a linear regression? So if we're using a y equals mx plus c, then you're going to yield about a 0.95 R-squared correlation compared to a second order polynomial. Bit of a pain in the ass when it comes to the programming side of the things, but if you're willing to take the time, it'll get you a stronger relationship of 0.99. Think about the change of technique. So if you're going to start at 30% and you're going to work your way up to 80, 85% or above, you're going to have a ballistic action turn into a strength action. So if you're thinking about the person spotting, if you're doing a bench press, think about how they have to change their technique from catching once you get to that 40, 50, 60% 1RM. Are they prepared to stop catching? Does the person throwing it know it's going to stop going in the air? All those sorts of things. Is a full profile actually required? Are you going to be using the full spectrum? If not, you can put more data points into your desired percent range. And then do you want to go to 1RM? So there's evidence to show, and we'll look at it in a sec, how you can use other rep ranges to figure out your MVT. So just quickly, this study highlights through 36 physically active males, which is the important part, that through loading from 60 through to 75%, their last rep, so there's 0 reps in reserve, you were a pretty similar MVT with only a 0.01 standard deviation and 3% variance. Okay, so I have a revised protocol. So I tried to start mine at about 55% and then do 6 data points all the way up to 100. For the first guy on the left here, we underestimated by a little bit, and he went over by about 15 kilos, so there's a few more data points. On the right here, we got it pretty close, we just added 1 more. So I used below 65% for 3 reps, 65 to 80% for 2 reps, and greater than 80% just 1 rep. The reason I added a couple of reps is because generally the first one is not always the fastest rep. Sometimes it's the second or the third that's actually the fastest, but you've also got to keep in mind fatigue. A couple of things with this. Athlete A was able to get 145 kilos at a 2 times body weight squat, and athlete B, very similar, 1.9, but only 110. With an MVT of 0.46 and 0.28. So that may suggest that potentially that athlete B has a lot more room for improvement just based on the fact that they can improve their technique. But does this technique actually result in performance benefits on the field or on the track? Okay, so this is where it starts to get a little more complicated. So for those who have maybe Team Builder or VCP, maybe a bit different, or even the paid version of Gymaware. But manually, this is how you calculate your trend. So through a function called a Linus function. So what we're going to do is we've got all our numbers here. We're going to use this Linus function at the top here. Here's the formula there. It's actually going to be an array formula, which means at the end you've got to hit Command Shift Enter, which will then stick some data further out past the cell that you've chosen to go in. So we're going to hit the Y values in here. Then we're going to go with the X values, but to the power of 1, 2, which means second order polynomial. Sorry if I'm breezing over this too quickly. A true will give you a y-intercept and false and return additional regression statistics, and then you hit your Command Shift Enter to make it the array. Okay, so we just have to try and remember using these 3 variables here. So now what do you do with the data? So whether you have Team Builder, Visual Coaching Pro, I'm not really sure. With Excel and Google Drive, I was able to make probably a pretty unique template. Can automate the force velocity profile into your programming just by tapping in your required percentage. So this is what my template looks like. It's probably pretty complicated from just looking at it now. But the main things are, at the top, you've got all your 1RMs. And then underneath that is the percent loading of that 1RM. So over time, I want to try and increase that percentage on that 1RM. And I've done that through some force-velocity profiling. So you can see I've got the exercises down here. If the exercise here, back squat, is then featured in my force-velocity equations, it goes through a big equation and it spits out what it says here. So if I'm going at 81%, it suggests that the athlete should be able to get 0.58. Okay, and the athlete will then write next to it what they were able to achieve, and then from there we can do some water regulation if we need to, which I'll talk about later. Probably the more important thing about when the number pops out, that's only for the first rep too. So the next thing is we're going to talk about velocity stops, and it's not the easiest thing if you don't have the paid version of GymAware. You've kind of got to do it manually, which is why I've included this next part afterwards. Once you've got those three numbers, the three variables, you can then poke that into the velocity equations part here, and then that way it will feed through there, through this massive equation. So for those who have used Excel and Drive before, this looks more complicated than it actually is. It's just a heap of new statements and different words and mumbo jumbo to make it look cool. But other than that, it's actually not bad. Okay, so if you don't have the paid version of GymAware, or even if you don't have GymAware at all, the next couple of slides will be helpful. I was going to put up a heap of different articles talking about how it relates to power, strength and hypertrophy, but Dan Baker summed it up pretty well in his 3-part VBT guide. And he just suggests that for maximal power output or improvement, you're looking at 5 to 15% velocity loss over a set. Strength, you're looking at 20 to 30%, and then hypertrophy greater than 40%. I'd probably tend to lean more towards the 20% for the strength. So what if you don't have a LPT? So if we take some work by these guys, I don't want to stuff up the name, it basically looks at a velocity loss of 15% versus 30%. So it was a 6-week squat program, utilising different loads here and figuring out whether the 15% or the 30% was greater in a range of different variables. So the important thing was you could just grab the information from a study and it just showed the amount of reps it actually took to lose that amount of velocity. So if you don't have an LPT or you don't use velocity-based training, you can just program a little bit smarter and just start to use some of these numbers. So if you're looking for improvements in 1RM or you're looking at improvements in counter movement jump, then you can program 10 reps to 50%. Hoping they have intent behind that, but all the way through you can go 6 reps, 5 reps, 4 reps, or 5 reps, and then 4, all the way through. So I read this and then I thought, well, what happens sort of above 70% when you're looking at heavier loads? So then I did a little bit of a study of my own. It didn't take too long, and it sounds really fancy, but it's not. I just took 4 of the top athletes that I have, 3 male and 1 female, 18 to 21 roughly. They were quite strong. I didn't deload them or put them through a tape or anything like that. I just wanted to look at the results throughout a normal training program. I told them just to keep lifting until I said stop. So I was looking at about a 20-25% cut-off. So what I had to do was I had to wait there with my phone and then hit in the initial velocity, punch in 0.8 or 0.85 to figure out what the velocity cut-off was. And so I found that from 75 upwards, basically you remove 1 or 2 reps all the way up to 90%. So the guidelines are 75%, you can go 4 to 6 reps, 80% 3 to 5, 85 3 to 4, and 90% 2 to 3. You're pushing it a little bit with the third one, but definitely 2. But you have to have intent behind the bar. So some way without your GymAware or your push, you've got to create intent. Alright, so the progressive overload point of view. So simply, systematically increasing demands on the body is necessary for further improvement. Perfect. If we look back at the earlier point about even a positive change in 1RM, the same percent lift yields a difference of only 0.0 to 0.1, so basically nothing. We have to think about how you want to progressively overload. So you want to allow the velocity change to dictate how you overload, or do you want to apply a bit of a guesstimation? So if you're improving your velocity and you can see that you can start to manipulate your progressive overload by using your previous change, so you're 1.25% or 0.02, you can do it that way. Or you can just think in a year where I want them to be. So if you take your strong squatter here at 145, it's potentially not going to increase that much in that year. Let's just say this is a weaker individual. If you're looking at a 20% overload, they're probably not going to improve 30 kilos in that whole year. You look at the 80 kilo squatter, looking at 10% annual overload, they can probably get another 8 kilos, so you may potentially push them up a little bit higher. This slide is here to make you sort of think about this one. So if we're looking at how we can use the velocity to guide our progressive overload, I've just put all these 0.6s here just to highlight that it's it's not going to change at 80%. It's always going to stay the same or thereabouts. If we start at week 1 or the week after we've done 1 RM and it's 145.29, you're still required to hit 0.6 and it's only a 0.3 increase. You follow that for 8 weeks, we've gone up by 2.3 kilos and you're still required to hit 0.6. If you keep doing that for 52 weeks, you're going to go all that there. It's a fair bit of change. All we ask them to do is just increase by a very small amount, 10% over that year, and all they're trying to do is just achieve that same 0.6 the whole year. Obviously that is not going to happen, you're not going to have a linear trend like that, it's just going to go up and down. But over the course of the year, if you keep improving or challenging them to go a little bit heavier but maintain the same velocity, you can potentially change their 1 RM by a fair bit. Okay, so auto regulation. The way I see it, you've got 3 different ways you can do this. You can adjust manually based on the velocity that they put out for either a close working set to where you want to start, so still your working set, so your warm-up set, or you can do it as part of your first rep for that range that you're looking at. So you can just look at it and go, if you're aiming for a 0.6 and they achieve a 0.62, then it's up to you to determine by your smallest worthwhile change if you then want to go up or down. If you decide that 0.02 is too small of a change and you want to wait for 0.04 to make an action, then you can. Number 2 is you can create a daily profile utilising the warm-up and working reps. Now, this takes a little bit longer and you can probably utilise it if you have a few more athletes. It's a bit hard with maybe 10, 20 athletes. Or number 3, you can have this equation ready to go in Google Drive or Excel and just punch in the velocity they got and it will tell you the intensity that they're working with. I'll show you just the equation here in case you really want to do it. But if you don't, you can just plug this in straight into your Excel, and then as soon as they hit that desired rep range that you're after, you plug in what they got in terms of their lift, and it will spit out what it suggests that you're working with, what intensity they're working with. So we're looking at about 0.65 to 77%. All right, so we're pretty close. This is the whole equation behind that, just put in there. All right, so we take that 77% at 0.65. But actually what they were required to do is they were required to get 0.58. So I think what happened in this situation was one of the athletes had gone away for a competition and they were dieting. They were in the habit of sort of leaving their dieting to the last minute, so they're quite fatigued during sort of the last couple of weeks before a competition. I think he came back and he was quite fresh and would still use the same equation. So he did the first set at 0.65, which is a 4% difference. So all that I did was just up that by 4%, which then changed the loads he had to lift. So initially it was 121, 125, 130, and went up to 125, 130, 135. Okay, so this is a direct quote from Dan Baker. He basically suggests, based on this, that it's not the idea of velocity-based training or regulation to use the daily profile. He suggests that you should use either the first or second method, where you're trying to get a change in the area that you're working on. Okay, so a couple of recommendations. Just think outside of the velocity zones box, that original one we saw at the start. It is a good guide, but start to think about how you can use it in your programming and potentially make something like this that I've done as well. Intent and feedback will improve performance. So if you're not too worried about the programming, or you are, if you give them enough intent or reason to move the bar quickly through augmented feedback by giving them their velocity after every rep, then more than likely they're going to improve their performance. Think about some smart protocol design. If you don't have an LPT, then maybe think about the reps that I was looking at before, but again, you've got to give them reason to create intent. You may just tell them to shake the bar or something like that. When you're also looking at protocol, look at a smaller range of loading, one you're actually going to use. Don't waste too much time thinking about the whole profile. Think about a change in technique. And then again, the more data points available in a certain area, the greater correlation you're going to get. And then you've got MPT, do you want to go to failure or not? I've utilised the second order polynomial because I've set up my template like that, and it creates a greater correlation. Think about whether you want to have a velocity change, dictate your progressive overload, or more of a guesstimation, and then maybe use a combination of both. And then auto-regulation and velocity change for a given load, so you can either solve for X or solve for every 1.25% for every 0.02. It's really up to you how you want to do it. So if you want to sort of find out more about the template, I've got a website, it's just myname.com, or there's some stuff on YouTube as well. I'd just like to thank Dylan for keeping these things going. It's a really good opportunity for coaches like me to get exposure in front of all you guys, and it really makes you think about the topic that you're interested as well. So references if you like, but yeah, thank you very much.